implementations, robotic application, real-time webcam, streaming, and performing some implementations like feature points, shooting down a specific object, a particular target for military or for law enforcement applications. And not only for military applications, we can use these applications for e-governance, for social sector. Using Raspberry Pi, Arduino board, using some actuators, we can work on very effective IoT deployments. And even in biomedical image processing, biomedical video analysis, for example, real-time data related to MRI, CT scan, ultrasound, we want to evaluate, we want to analyze. Using OpenCV and similar platforms, we can work out. Along with OpenCV, there are lots of other platforms available which we can integrate for key feature detection, for identifying a specific disease, whether it is a tumor or some other abnormal object in human body. Real-time object detection, number plate detection using optical character recognition, and similar domains we can deploy. So in real-time video analysis, real-time video feature detection, lots of things available, not only edge detection, not only specific corner detection or key features, internal details related to specific image or video can be evaluated. So for law enforcement, seen at the time of lockdown or curfew, such things are implemented for real-time object detection, identification of movement of something, whether it is human being or any other object. For traffic lights also, we will be able to work out. Okay, so these are very good, very effective implementations and real-time case studies related to computer vision, which we can implement using OpenCV. Face emotion recognition, real-time facial expression recognition, lots of pre-trained applications available, lots of cloud-based platforms available which we can use. From somebody's face, we want to identify whether a specific person is happy or not, contented or not. Using facial expression recognition, we can identify, we can even such implementations can be used in education, in academics, in online sessions. For example, we want to propose a research project to government agencies that using webcam streaming, we want to identify the actual face, that whether actual participant is attending the session or not, whether participants are satisfied or not, they are contented or not with the content. So that may be an area of research or case study related to facial expression recognition, real-time webcam streaming, analytics, and performing KYC or emotions evaluation. Okay. So when we discuss about these applications, for example, real-time number plate detection or real-time object detection, you might have seen that in deep learning, in high performance applications, we need to use graphic cards or TPU, that is tensor processing unit. When we work with Google Colab, specifically in deep learning, we have to use TPU or GPU, graphic processing unit, graphic cards or TPUs. So if we are working on some research project, very lightweight research project and low resource application, then how to use graphic card. So nowadays neural compute sticks are available. It is basically a USB device. Okay, so if we are working on some law enforcement application, some military applications, drag and drop based, simply plug in plug out based USB stick is available, neural compute stick that can be integrated in Raspberry Pi, that can be attached in Arduino board or BeagleBone Black. Okay. In agriculture domains also, agriculture domain agribots, if we are working on some robotic applications for agriculture sector, we want to perform. So all of these applications are associated with IoT as well as artificial intelligence with computer vision. Okay, nowadays we are in the era of multidisciplinary research rather than only computer vision. We have to integrate different other technologies, artificial intelligence. We have to integrate wireless networks. We have to integrate very lightweight communication protocols, MQTT, AMQP, LoRaWAN. And when we merge all of these technologies, then we are able to work on, we are able to deploy very effective research-based applications. Okay. Now we will see which are those applications, which are those platforms available. So up to now, you might have covered OpenCV, different domains, but along with OpenCV or in association with OpenCV, lots of other platforms available. Okay. So I'm showing you Luminous AI, okay, Lobe AI. So if we want to work on such type of applications, machine learning, deep learning based applications, and real-time object evaluation, LOB, completely free and open source. And at the back end of this, there is OpenCV. Okay, so you can see that even Luminous AI and lots of other platforms which we can use. Okay. If we want to use it for agriculture, hand gesture recognition, or we want to use it for medical domain to evaluate face, to identify a specific object, for marine applications. Okay, monitoring of a specific object, monitoring of some particular person, their activities, whether it is while driving or while sleeping, whether awake or not, and fire watching in fire control, scientific research. We want to identify a specific virus, a particular viral infection in human body, movement of a particular object in industrial automation. And at the back end of all of these, OpenAI works. Okay, however, it is Microsoft-based platform, but at back end of it, OpenAI can be integrated. OpenCV, OpenAI, so many other platforms. Lobe is there, Luminous is there. Okay, so these links I have given YOLO that we will be able to work. Okay. BoofCV, that is also OpenCV based, completely free and open source, very lightweight applications related to computer vision, video analytics, image processing, we can work out. So its source code is also available. In multiple programming languages, we will be able to program. If we are comfortable in Java, if we want to program it in Python or other programming language, we can perform it in multiple programming languages. OpenCV is not only dependent on Python, even in C++, in Java, Node.js, we can program it. Okay. So different examples are also available. As per the schedule, I will start the demonstration of real-time object detection also. Okay, but first of all, we are covering about different case studies, different aspects of real-time object detection, real-time video analytics, and related platforms. Okay, so you are already aware with these things. OpenCV, that is having each and everything, all algorithms related to computer vision. If we are working on facial expression recognition, facial recognition analysis, gesture recognitions, it can be programmed in OpenCV. If we are working on image fingerprinting or video fingerprinting, video security, we can work out. Most of the algorithms, most of the approaches which are related to image and video, these are already programmed in OpenCV. If we are working on, for example, random forest approach or naive Bayes classifier, if we are working on neural networks, we want to, if our area of research is related to support vector machine and we want to implement on some particular videos, then no need to program classical approach. In research, you might have seen, as all of you are researchers, you might have seen in research what we do. First of all, we have to implement classical approach, previous approach, existing approach, and after that, with modification in code, with modification in mathematical formulation, we have to propose new results. And then we compare proposed outcome with existing outcome. Okay. As far as OpenCV is concerned, existing approach or previous approach, these are already programmed. Different algorithms are already available. So no need to work specifically on classical approaches. Only we can work on proposed approach with modification in the source code given in OpenCV platform. And in multiple operating systems, we can work. Whatever operating system you are having, Linux, Mac, iOS, you can program in OpenCV, and its CUDA support is also available. Compute Unified Device Architecture for high performance computations. Even on Android phones, we can program it. Okay. So up to now, you are already aware with different basics related to computer vision, related to OpenCV. Now we will see by which way we can work on feature points analysis, feature point detection in computer vision using OpenCV. There are different ways. Either we can take a static video in MP4 format or in MPEG format, and we can go for feature point detection. Lots of feature point detection techniques available. And as far as video processing is concerned, you might be aware that each and every video is a sequence of frames. Each and every video is a sequence of images. Number of images gets executed in sequence at a particular time span, at a particular timestamp. Okay, in a specific frequency, number of frames gets executed. And when these thousands of frames gets executed, and we club it, we merge it in a specific file, it forms a video. Okay, so most of the algorithms are same which we use in image processing, Schitomasi algorithm, edge detection. If we want to work with corner detection, then Harris corner approach is available. As far as difference is concerned, video capturing, the format of video capturing, in which way we have to capture the data, that is the point. And once data is captured by webcam or by static image, then we go for extraction of individual frames. As far as individual frame extraction is concerned, there are different applications. One application, if we want to identify feature points, we want to identify edges. Another is video shot detection. We want to see the gradual changes. We want to see divergence in video, because whenever we watch some particular movie, whether it is a web series or a particular movie or a particular video, it is not shot in a single timestamp. It is not shot in single layer. In any episode, in any particular video, there are number of sequences, number of shots. So video shot detection, that is another area of research in video analysis. You might have seen that when some advertisement is to be inserted in a video, then we have to identify shots. In between a video, if we want to insert advertisement or some sponsorship, first of all, we have to identify shots, and then we have to put that specific video. That is another area that we will cover in next session, but currently we are discussing about feature points analysis and feature point detection of different algorithms using different approaches, either by machine learning or deep learning. In both ways we can implement. Okay, so feature points by which are different application areas of feature point detection. First of all, we should be clear about the base properties of feature points, whether it is related to image or it is related to video. It should be independent of scaling, rotation, and transformation. Feature points. For example, we have a video or image of specific person. If we rotate it, or if we resize it, if we zoom in or zoom out, or scale down or scale up, its features should be same. You might have covered different algorithms related to features like shift, surf, fast surf. Hundreds of algorithms available which are transformation dependent and some are transformation independent. But effectiveness of algorithm lies with independence. Okay, it should be independent of transformation. If we have a human face and we are rotating it to 20-degree clockwise or anti-clockwise, its features should not be modified. Okay, we should be able to identify that person. We should be able to identify that object. In real-time number plate detection, for example, a specific vehicle is moving, from whatever direction it is coming, whatever orientation it is coming, your algorithm should be able to identify the number plate. Okay, it should not be in that way that it is coming at this particular distance. It should be of this particular scale. From whatever direction it is coming, from whatever orientation or scale it is available, your algorithm should be able to identify what is written on the number plate. Okay. In medical images also, in medical imaging, bioinformatics also, if we are using feature point detection on ultrasound streaming, on MRI or X-ray, then it should be independent of rotation, it should be independent of the scale or independent of the device, from using which device, using which company's device it is recorded. So lots of algorithms, lots of case studies, different use cases, applications available in computer vision, in image processing, for forensic applications, for computer vision based analysis, even video forgery detection, even signature forgery detection, or document forgery analysis, we can use these approaches. Are you getting the content? Kindly confirm. Are you getting the content and audio as well as video in chat window? Kindly write. Is this clear to all of you up to this point?
Yes, sir.
Are you getting audio and video properly? Okay. So these are very basics related to computer vision, related to image processing, image properties, and different techniques. First of all, we will see which are different techniques related to feature point detection, that is also known as key feature detection. One of the very classical and prominent technique that is used in computer vision, in image processing, video processing, is edge analysis, corner or edge analysis. Okay, very soon I will start demonstration also. I will show you demonstration on some videos on real-time webcam also. But before any demonstration, first of all, we are covering the concepts. We are covering different aspects related to the paradigm. Okay, edge detection, corner detection. As far as edge detection or corner detection is concerned, it is able to identify those objects, or it is able to classify those objects which are of different shapes. For example, our research work or our implementation is related to identifying different types of vehicles. Okay, identification of different types of vehicles, we can use edge detection or corner detection. Car, bus, truck, bicycle, bike. So these objects are having different shapes, different scales. Okay, if we leave scaling point, because feature point detection should be scale invariant. Okay, scale independent. So in that case, we can use, if we want to identify different types of animals, in that case also edge detection, corner detection, it can be used, because each and every animal, most of the animals, most of the creatures have their own shape, they have their own dimension. In agriculture domain also, different objects or different outcomes, they have their own shape or orientations. But what about those area, what about those domains where same type of object to be identified? For example, two human beings or set of human beings. If we want to identify set of human beings or classify out of n number of human beings, in that case, corner or edge detection will fail. Okay, 100 different types of objects, set of human beings, set of criminals, so anybody can make fool by making changes to the hairstyle, making changes to some particular object. Okay, but anyway, edge detection, corner detection, that is one domain, that is one part, and that we can implement some scripts I have already taken. For example, we want to work on Harris corner edge detection. So I am opening this code. Some scripts I am already having, and I will explain it. In OpenCV, these algorithms are already available. So this one is Notepad++, and in Notepad++, I'm showing you some scripts and on which image we want to implement that algorithm. So this one is CV2. So if we want to import, if we want to work with OpenCV, we use CV2. Okay. Each and every video is a sequence of images. Each and every image is a matrix. Okay, everybody knows about it. If you are already aware with image processing, video processing, every video is a sequence of images, and each and every image is a matrix at the back end. So if we want to work with matrices in Python, we have to use NumPy. Okay, if we are not using NumPy, in that case, we will not be able to work on matrix manipulations, matrix operations. On which image or video, for example, I'm opening one video or image. First of all, we will see it on image, and then we will implement it on video also. So this one is image. On this video, on this particular image, we want to implement. So this image path, this image name we have specified. If I want to implement it on video, so simply what we will do, cv2.video capture. So we will see that part also. Okay, and using Harris corner approach. Using Harris corner, so Harris corner algorithm is available in this format, corner Harris. Okay. So Python corner Harris. So we want to identify any other object also we can take. For example, we want to take any other object. Java.png. So corners are identified. So this one is on a classical image. If I want to perform it on a video, so code will be same. You will see. So I'm opening both codes. One is Harris corner on image, and second Harris corner on real-time video. So this one is. So these are two scripts. In image processing, in image analytics, we are using cv2.imread image name, image path, and here we are using cv2.video capture. cv2.video capture means we want to stream, we want to capture video from webcam, from live webcam. Whosoever is in front of the camera, and its index we can put 0, 1. You might have seen nowadays we are using multiple cameras in different establishments. For example, I want to fetch streaming from 5th camera, 4. I want to capture streaming from default camera, from first camera, default 0. And whosoever is in front of the camera, its video will be captured, and on that video we will be able to implement our algorithm. So this is corner Harris, and you can see that this one is same code. Or this one is CV2.corner Harris. We are converting it to float 32, converting to float 32, CVT color, BGR to gray, CVT color, BGR to gray. Script will be same. Major thing is that we are changing the type of data capturing. Okay, now Python Harris corner on webcam. I'm sitting in front of the camera, so you can see that at backend we are having these feature points. So if I'm showing you, so you can see that different key points. Okay, so if I'm showing you my mobile phone also, so it is able to identify that particular edge also. Okay, so real time, so whatever object is there at background, its features will be identified. Okay, and these are the key features. We can record these features in Excel format. We can save these features in CSV format. If we want to use it for machine learning, for example, I want to train a data set. I want to train a data set of different human beings, different persons. And using machine learning, we want to identify, we want to recognize somebody. So we can perform it. Okay, so these are key feature points. And as far as this algorithm is concerned, for example, I'm working on improved Harris corner algorithm. You might have seen in research, we work with improved approach, improved genetic algorithm approach, improved watermarking approach, improved approach for security and privacy in this domain. If I want to work with improved Harris corner technique, then first of all, there is no need to code for of this particular technique separately. It is already available. Its source code is already available. So because you might be thinking that from where this particular code is available, from where this particular code can be taken, and you can see its code is around 15 to 16 lines in very less lines of code. So you can see that this one, corner Harris technique, and this one is the source code. So from same portal, I have taken this code for demonstration. And in research papers, in documents, in research reports, we have to give theoretical aspects also. We have to give mathematical formulation also, by which way Harris corner technique works, by which way this algorithm is giving the output, it is identifying. Okay, so it is given in this presentation also. What is corner Harris? Okay. To simply identification of sharp turns or joints in image, division of a particular image into multiple parts, into different grids. Each and every grid is identified in form of brightness and contrast. So obviously, if you want to see, there is a big turn or sharp turn between two grids, then it will be considered as a specific edge. So you can see this one is the source code. This is the same source code. Here, rather than using this particular image, we can give CV2.video capture. If I want to work with C++, this is C++ code available on official portal, official documentation site of OpenCV. If I am comfortable in Java Swing based application. Okay, if same application I want to deploy for Java project. If you want to work with Python, this is Python script. Okay, and This one is the mathematical formulation, algorithmic approach by which way it is implemented. So if I want to work with improved Harris Corner approach, so base code we can take from here in whatever programming language we are working. Even if I'm working in MATLAB, so MATLAB script, Scilab script, GNU Octave script, that is also available. So this one is base code of Corner Harris. And so what we can do initially, we can note down its reading, in how much time it is giving us the output, and using improved approach, we can note down how much time it is taking in improved technique. Okay, so if you want to see it, if you want to give any image or webcam, so again I'm showing you at backend Harris webcam. Harris Corner webcam. So current initially it is 0, and as soon as it is streaming data, so on a real time video, it is identifying the edges using Corner Harris. To save it, if I want to save it, this output, if I want to save this result in a format, for example, I want to save it in features.txt or features.csv, you can do it. Okay, redirection operator, features, you can perform it. In this particular case, features will not be available on screen. It will be saved in features.txt file. If I'm working on machine learning, now type features.txt. Now you can see that this particular file is available. I'm showing you this file in this 68 KB. You can see that instantly we have created a data set of 68 KB. So these are the feature points taken from webcam, and I can use these features to train a machine learning model or deep learning model. Okay, if I'm using artificial neural network, random forest approach, any classifier, so we can use this data for training in a neural network or machine learning or deep learning model. If I want to use 1D convolutional network or LSTM, we can train n number of persons, n number of data or objects data can be trained. Okay. Is this clear to all of you up to this point? Is it clear to all participants? Kindly confirm.
Yes, sir. Yes, sir.
And
so this works under Python 2.7?
Yes, sir. I'm having version 2.7 as well as 3. Okay, both I'm having.
But will it work in both?
Yes, sir. It will work on both.
Okay. We don't have to make any changes, special changes.
No, sir. At end of this session, I will share this source code to you so that you will be able to execute it.
Yeah, that's good. We are using Python 3.9 something.
Yes, sir. Both. So you can see that this one is. So I'm using Anaconda also.
Okay, great.
Okay.
Right. Thank you.
I'm using both prompts, Anaconda. So you can see this is Anaconda 3 and Python 2. So on both variants, we are able to work.
Perfect. Thank you, sir.
Okay, so you can see related to any particular object, if you want to save a data set. Okay, for example, Harris Corner, and this one is on image and flower.txt. And now we want to check the features which are taken. So this one is flower.txt, features.txt. Okay. If we want to use a particular AVI file, that can also be done. Okay. AVI file, MP4 file, on any file we will be able to work. So this one is Harris Corner, very first approach.
Excuse me, sir, what do you do with this kind of data, what you have collected? How we can take meaning out of this?
Okay. So this data we can use if we are working on machine learning. For example, we want to classify n number of persons. For example, we have 10 objects. We want to classify those 10 objects. So what we can do, so data set can be trained. So if we have worked on machine learning or deep learning, so what we can do, we can train this data in a model, in artificial neural network, in AI based model. And after that, whatever object is in front of the camera, it will predict that what is accuracy of this person to be that person. So for example, in biometric applications, in biometric, what we do, when you give nowadays in most of the organizations, fingerprint or face based biometric is available, biometric attendance. But before that, you might have given your data set. When initially biometric machines were implemented, were deployed in your institution, you might have given your data set, your readings. Initial readings were given by each and every person. It is trained in neural network, it is trained in machine learning model. And after that, when you are appearing every day in front of the camera, then it is predicting that it is you. Are you getting this point?
Yeah, I got your point. Yeah, that's right.
Okay. So
actually, out of number of people, it can recognize a particular person also.
Yes, sir. Actually, in every biometric machine, there is machine learning, there is deep learning, artificial intelligence. So whether it is fingerprint based or it is image based or webcam based. So first of all, we have to give a data set. So once data set is given, it will train, and after that it will predict.
Right.
Okay. So this is one approach, Harris Corner algorithm, that I have mentioned in this presentation. So by which way it is done? Division of a particular object, a specific image or video, and then identification of grids. Then next approach, that is Shito-Masi algorithm, refinement. It is improved Harris Corner technique that works on eigenvalues. Okay, mathematical calculations on each pixel. So improved version of Harris Corner, that is Shito-Masi, and it is also available on OpenCV portal for image analytics as well as video analytics. As far as its working pattern is concerned, it is more focused towards pixel values and interior pixel parameters, which are known as eigenvalues. In mathematics, you might have heard this particular term, eigenvalue, eigencalculations. So what about the relationship of pixels with its neighborhoods? What about the brightness? What about its color aspects? So for that, Shito-Masi approach is used. Rather than viewing only specific points. So Shito-Masi. So you can see that in very less lines of code, in 6 to 7 lines of code, 10 to 15 lines of code, we are able to work. So you can see good features to track. Sheetomacy for which image. So good features to track, OpenCV. And all of these scripts are available in free and open source distribution. Okay. Sheetomacy algorithm, and on webcam or on static video or on static image we can perform it. On a specific static image, so in this way. So whether it is classical edges, so as I am in front of the camera, so it is identifying only edges. So whether it is a Sheetomacy algorithm or classical edge detection approach, so I'm taking mobile in my hands, so you can see that it is identifying only those parts. And if you want to print it, if I want to print so this one is source code, and even on live mobile camera also we can use it on live mobile camera. Okay, so if you want to capture features from your mobile phone camera, it can be done. Okay, so Sheetomacy algorithm, Canny edge detection, or Harris corner algorithm. So if you want to take using your mobile camera, so I'm showing you that process also. On your systems you will be able to implement. Okay, in live demonstration mode I'm not showing you its demonstration because it will take lots of resources. Okay, IP camera, so I'm showing you the process. It is given in presentation also. So this software you can download and install any IP cameras. Code I am sharing, all of these scripts I am sharing to you so that you will be able to work on your systems. I will share this presentation as well as code so that you will be able to work. Some scripts also I'm taking geometry and I'm creating a folder so that I will be able to share this code to you. Dear participants, I'm sharing this code as well as a presentation so that you can work, and I will share it via cloud link. Very soon it will be shared on your chat window. Dear participants, kindly confirm is it downloadable or not. One link I have shared in chat window. Click on this link and download, and kindly confirm is it downloadable or not. I am not having access to Google Classroom, so any of you can upload, or coordinator sir will upload it. If you have any query related to this session, you can ask whatever we have covered in this session. If you have any query, you can ask. Session is open for your queries. If you have any query, you can ask. After that, we will have a break. Okay, if there is no query, then we are having a short break. At 11:35, we will start next session. Okay, around 11:35, we will start next session. You have a short break of 20 minutes. Dear participants, we are starting this session. Dear all, I am sharing my screen. Kindly confirm in chat window, is it audible and visible to all of you? Okay, so in this session, we will cover another aspect of video processing, that is video shot detection. In video shot detection, there are different points. As far as video shot boundary detection or video shot detection, if you want to identify different sequences, okay, but before video shot boundary detection, first of all we will see its related part, that is background subtraction, because both of these are interrelated. For example, we are working on some forensic application. In forensic application, in video morphing, in video forgery detection, we want to identify some key points. For example, in this video, you can see different objects, different human beings, and we want to identify those objects only. So background subtraction using MOG approach. In Python 2, it is GMG. Okay, so any of these you can use. So I have commented these lines. If you are using Python 2, then which to be implemented. And in OpenCV documentation, motion analysis, background subtractor for motion analysis, and after that we will see video shot boundary detection. So this one is official documentation. And complete API list that we can use. Gaussian mixture background, GMG, MOG, and from that specific video, so you can see that from actual video. So in actual video, there is some background, there are some objects, some still objects, but here with background subtraction in video shot. So such type of implementation, where we can use such implementations for military domains, for military applications, for laser based applications. You might have seen in border area, in international border area, or in some particular locations, there are some points where any movement is not allowed, whether it is human movement or any creature's movement. And we want to identify that particular movement in a specific domain. Intruders detection. And it can be done with live webcam also, real-time webcam also. So it is implemented on MPEG file, MP4 file, AVI file can also be integrated. But if we want to use it for drones, for example, you are using some drone, you are proposing some research project and you want to identify those objects. So this is actual video. This one is actual video. So whether it is daytime or night mode, any intruder's movement, any intruder's activities can be logged in. So this is actual video. And from this actual video, we want to see this one. So I'm opening this. We want to identify some shots, some movements. And as far as its script is concerned, you can see that. So if I want to capture from video from webcam or CCTV, so CV2.video capture, and but here we are using one AVI file, so pedestrian.avi file, and background subtractor emoji by default available. Okay, background subtractor. How to create background subtraction? So this one is the approach. So this technique is used. BS, background subtraction, current frame, background model, and depending upon some threshold, we want to see only movement area, and in which programming language we want to program, C++, Java, Python, in same way as we have seen earlier also. For example, this, so this is the video. So this video I have downloaded. Yes, definitely we will have to install thermal cameras. So as there is one query from Professor Sanjay Kumar that whether thermal cameras are required. Okay. So for better clarity, thermal cameras will be required. So in this case, you can see that. So however, it is implemented on static image, but on a particular video, we can implement. We test.avi file, you will be able to work. Any other file you can take. Depending upon the clarity of video. So this one is airport. Okay. From airport streaming, airport webcam streaming. Or classical image. So in online session, we have to be very careful about the resources. So I'm not taking very large videos because lots of bandwidth will be consumed, lots of resources will be consumed, and there may be delay. So on small videos, we can implement. Any of these you can take. It's API if you want to extract. It's API level we want to analyze. In whatever language, and different algorithms are available. So you can see GSOC, LSBP. So you can go through it. GSOC approach. So these are different algorithms. So if you are working on some algorithm, you can take. LSPP. any other video or real-time webcam you can take. So this one. So if you want to work with these algorithms, so these can also be implemented on videos. So shift if you are working on image processing, video processing, or similar domain. So you can see X shift features 2D shift create. So if you want to work with shift surf, these algorithms are also available. So X features shift underscore create. In OpenCV, all of these algorithms are pre-programmed. Shift underscore create, X features 2D, shift surf, fast surf, ORB detector. So features, feature extraction, which features ORB shift surf, features fast, whether it is from image or from video. If you want to perform on video, then CV2.video capture. Okay. So these scripts I'm placing on desktop so that I will, at the end of this session, I will give it to you. So whatever scripts I'm running, I will share at the end of this session. Okay. Now, dear participants, we are discussing about another domain, another segment, that is video shot boundary detection. Very important and new area of research in image and video processing, in video analytics, multimedia data analytics. In computer vision, lots of work is already done. Lots of implementations are already available. But on this domain, very less work is done. Many times researchers struggle for new areas of research in image security, in video security, in streaming security. So this is the domain that you can take. Video shot boundary detection. In this, what we do, how to identify a particular shot, from which sequence to which other sequence a specific video is shot. We want to identify forgery. Major application of video shot boundary detection is forgery detection. If from a particular camera, for example, a video is shot for 10 seconds, so and from 11th second another shot is taken, so we can check what is the actual shot, what is the actual stream, frame 0 to frame 9, that is 10 frames. Frame 10 onwards, another set of frames, transition of frames. So in video shot boundary detection, what we do, we identify those features, those frames which are shot, which are recorded at a particular timestamp. If there is additional frame in between a particular shot, then it can be identified as forgery. For example, you might have seen in many instances, specifically in political instances, somebody says that I was not present in that video, I am not part of that video, still my image, still my video is available. Identification of forgery in CD, DVD, in recorded media, whether it is same object whether it is the same recording or different. So these are different use cases, not only for forgery. To evaluate a particular scenario in sports activity, extraction of advertisements. Few days ago, you might have seen at the time of World Cup final match, cricket match, there was a controversy in that particular catch at boundary. Okay, near to boundary, there is controversy. So using forensic analysis, it can be identified whether somebody has inserted a new video of manipulation in boundary or not, whether it was actual or not. So using video shot boundary detection, it can be easily identified whether it is forged video in which it is told that particular foot was touched on boundary. That is one use case. Insertion of advertisement, ad film in movie. Extraction of particular frames, noise removal, and fingerprinting. Extraction of advertisements from a video. You might have seen when we upload. So as a YouTuber, I think many of you might be involved in uploading YouTube videos. So how to extract or insert advertisements within video. So when we upload one video on YouTube, in between YouTube video frames, YouTube organizers, they put some advertisements in between. So by which algorithm it is done? So whether it is a web series or episode or video, in between transition of frames, rather than abruptly inserting frames or advertisement, we can see where is completion of one frame. If there is completion of one shot, after that we can put a video of 8 seconds or 10 seconds. Okay, in sports activities, it is widely used. Currently, it is an area of research. So you can also propose some good research projects related to forgery detection, related to boundary analysis, whether somebody was actually present or not, whether some forgery was done or not in video, just to show it fake. Okay. Are you getting these points up to this point? Are you getting whatever we are covering? Kindly write in chat. Okay, so which are different segments in a video, different scenes. Within different scenes, there are different shots. Okay. And for which application, for which purpose we want to use, we can use it for summarization, for indexing, for retrieval and editing. So inside video, there are different scenes. Inside every scene, there are different shots, and we can check different shots. So you can also perform short editing, short manipulations, short evaluations, whether it is actual or not, whether somebody has put additional frames within video or not. If there are additional frames within video, it will be identified. It will be easily caught that some manipulation is done in this video, and that's why there is controversy. But actually, it is completely plain. It is completely truth level. Okay. So process to identify transition between different shots. A particular recorded video, obviously it is applicable and it is effective for recorded video, for real-time streaming, For live camera, it is not very effective, because for live camera, obviously, it is a single shot. In a recorded video, in historical video, for forensic analysis, we can check if there is modification in a specific shot or not. And once that particular video is extracted, once that video shot analysis is done, we can summarize it. So summarize means, for example, a video of 2 hours, we want to confine it in 20 minutes. We want to shorten a particular video in short time span. Now we will see how to work on this particular implementation, video shot detection. There are different ways. One way is related to machine learning, deep learning, using data sets. Lots of data sets available, video data sets available. If you want to work on video data sets, so samplevideos.com. If you want to work with machine learning based approaches, deep learning based approaches, and we want to download some sample videos for our research. If you are doing research in machine learning, if you are doing research in multimedia or computer vision, you might be in need of some images, royalty-free images. So you can see that these videos are available, images as well as videos. For example, I need 1000 videos for testing for my algorithm. So from where I will shot 1000 videos, it will be very hectic. It may be very problematic. But here you can see in MP4, in FLV format, MKV, 3GP format. For example, I'm downloading this video just for demonstration. Okay, this one. I want to download some cartoon movie, some web series for my research. Even I want to download some movie for experiments. So you can see that this one, click, and it is downloaded. I am running it. I can train a data set. So you can see this one. Samplevideos.com. It is benchmark source. Sample, not only videos, if you need sample PDF files for your research, 1000 PDF files, 1000 AVI files, MP3 files, MP4 files, you can use these resources. And another source, Blender Studio. So lots of cartoon movies, lots of web series, lots of animations are available for research. If I want to perform, for example, canny edge detection, I want to perform video shot detection. I want to, so as a machine learning programmer, as a deep learning programmer, I want to train a data set of all videos which are related to boundaries. So I'm again coming to that point because of the lots of controversy. So what we can do, we can train a data set in which lots of images are available, lots of streamings are available related to boundaries, cricket stadium boundary. Training of that data set, and after that, whatever video we want to check whether it is fake or it is genuine, we can match it. Okay, training a data set. For example, we have taken all videos from BCCI or from ICC. We have trained it in neural network, in convolutional neural network or LSTM. Trained model is achieved. Once trained model is available, then whatever video we want to see, whether it is fake or not, we can check, we can match it, and it will show that it is matching 60%, it is matching 70%, or in form of 0 or 1. If we want to check a particular cartoon movie, for example, we have a cartoon movie, cartoon episode, and we want to check whether it is true or not. Just for an example, I'm taking Mickey Mouse. Okay, I want to check whether a particular video of Mickey Mouse is actual or not, it is fake or genuine. First of all, I will take all videos or n number of videos related to that object, related to that character from Disney World or from wherever it is available. Okay, Sony, Disney World or Hotstar, whatever it is. We will train it convolutional neural network or RNN or GRU, and then whatever video we want to check whether it is fake or it is genuine, we will match it. Then it will show that it is whether it is matching or not. So this is data set based prediction, data set based evaluation. Data set for, so there is one query related to video shorts for traffic. So these are also available traffic. So these links I'm giving you. So on this you can check. So archive.org. Archive.org. In this on this portal you will get different videos related to different scenarios, traffic, geospatial data, okay, movies. So matches. So you can see this one, football match. Okay, football matches, cricket matches. So this one is Mahabharat Telugu. So different data sets are available, which we can train in deep learning, in machine learning model. Majorly, it will be used in deep learning because we are having images, we are having multimedia data set. So you can search for traffic, you can search for airports, air traffic, or anything. So you can see Mahabharata episode from 1 to 267. So all episodes are available. You can download it, you can train it. Its deep learning model will be trained. And once it is trained, then we can check genuineness of any episode, genuineness of any video shot, whether it is genuine or fake. Okay, community video, and all of these are available for research. Okay, so you can see that how many files available. Related to any domain, you can search for the videos. So archive.org. So you can see television programs, collections, art, music, spirituality, religion. Okay. Related to everything, short videos, news channels, YouTubers, everything is available here. These you can use for forgery detection for your analysis. Now we will see, now once this data set is available, we can train it. And once it is trained, we can match our upcoming videos, whether these are fake or not. So these are some more resources: AVA dataset, research.google.com. So if you are working on geospatial data, satellite videos, these are available. So you can see kinetic data set from DeepMind, AVA. So these data sets are very useful for research. And kinetic data set. Flickr video data set. If you are searching for data sets related to some sports activities, some matches, some tournaments, Olympics, these are also available. So you can download it. So action data set related to different actions. Action recognition data set. So you can see that playing activities, typing. Okay, so many human actions, these data sets are available. We can train in AI model, and then we can go for its prediction. So video level annotations are also available. Now, once this data set is trained, after that, what we have to do? Which algorithms are available for video short detection, video forgery analysis, or short boundary detection? First of all, we'll see different types of boundaries, different types of short boundaries. Two types. There are majorly two segments. One is hard cut, and second is gradual or soft cut. Okay, soft cut or hard cut. In movies, in web series, in different episodes, you might have seen sudden switching a scene from one location to other location. For example, one scene is in living room and second scene is in park or in some restaurant. So it is clearly visible that these are two shots. These are two different shots. And it can be easily identified. No need to use any algorithm. In prima facie, it will be visible that there is hard cut and video short boundary is analyzed. Abrupt transition from one shot to another without any intermediate frames. Intermediate frame means many times you might have seen some transition effect. Intermediate frames. In soft cut, we perform it. In soft cut, you might have seen fading in, fading out, or some intermediate blending is done, some particular swings, some waves are given, patterns or motions. So dissolve, fade, wipe. In gradual cuts, it is done. So two types of video short boundaries. Smooth transitions, dissolves, fades or wipes. In case of hard cut, abrupt transition, one scene, another scene, and then it is recorded. Now, whatever approach we are using, whatever type we want to analyze, for example, we are analyzing gradual cut, or actually video short boundary detection, major motive of video short boundary detection is to analyze internal shots between hard cut or in soft cuts. Okay, For example, one scene is there in which 20 frames are there. Within frame 0 to 20, is there any manipulation or not? We want to go for evaluation of each and every frame. Now, by which way it is done? So these are two transitions, different techniques for video short boundary detection. These are major techniques. Either we go for pixel-based approach, histogram-based, edge, transform, or machine learning-based techniques to identify video shots. One by one, we will see. First of all, we will discuss about these approaches in concept, and after that, I will show you its demonstration. Okay, it's demonstration on Python with some video, MP4 video. Pixel-based approaches. Comparison of pixel values in consecutive frames, in different frames. For example, in this very first slide, you might have seen pixel intensity. So what is pixel intensity in first frame, in second frame? Is there any abrupt change? So here in last 3 frames, is there any abrupt change in pixel intensity? If we are only analyzing this part, in that case, it will be pixel-based approach. Calculation of absolute differences, sum of absolute differences between pixels of consecutive frames. Histogram-based, we can generate histograms in different image editing software, in different image editing tools you might have seen. We generate histograms in Photoshop. Also histograms are generated in video editing software, in Blender, in Maya, in 3D Max, in Cinema 4D. Histogram evaluations can be done in React.js, Node.js. Histogram evaluations can be done. Edge-based approaches. If we want to analyze edges or contours. So in this case, again, we have to use Canny edge detector. We have to use Shi-Tomasi algorithm. We have to use Harris Corner algorithm. So using edge detection techniques, we can see whether this diversion is possible or not, whether this particular frame diversion, this frame transformation is feasible or not. And edge-based approach, machine learning-based approach, transform-based approach, in which we go for wavelet transformation, wavelet coefficients, and machine learning. It is widely used. This is a major technique that is used nowadays. It may be supervised or unsupervised. For example, we have taken a data set of some sports activity. Okay, we have taken all recorded videos from organizers. We have trained it with CNN or with RNN. And then we want to predict, we want to check